My name is Caleb Atkins, and this short presentation explains electric current, one of the most fundamental ideas in electrical systems. Over the next few minutes, I'll define current, explain how it forms, describe its direction, show how to calculate it, and finish with how we measure it. Every material is made of atoms that contain positively charged protons in the nucleus and negatively charged electrons orbiting around it. In metals such as copper, some electrons are only loosely bound to their atoms, which allows them to move freely when a voltage is applied. This movement of electrons is what we call electric charge flow. 1 coulomb of charge equals about 6.24 times 10 to the 18 electrons. Electric current is simply the rate at which electric charge flows through the conductor. It's represented by the symbol I and defined by the equation I equals Q over T, where Q is charge in coulombs and T is time in seconds. If 1 coulomb of charge passes a point each second, the current is 1 ampere. In other words, current measures how fast charge moves through the circuit. For current to exist, there must be a potential difference or voltage. A battery provides this push by placing a positive charge at one end of the conductor and a negative charge at the other. The negative side repels electrons and the positive side attracts them, causing a continuous flow. So voltage is like pressure, and current is the motion that results from this pressure. The electrons themselves move from the negative terminal towards the positive terminal. However, by convention, engineers define current as flowing in the opposite direction, from positive to negative. This is called the conventional current direction. Both describe the same flow of charge, they're just two ways of viewing it. Let's look at two quick examples. In the first, 0.16 coulombs of charge pass through a wire in 64 milliseconds. Using I equals Q over T, we divide 0.06 by 0.064 and find a current of 2.5 amperes. In the second, 5 times 10 to the 16th electrons pass a point in 1.28 seconds. Converting electrons to coulombs gives 0.008, and dividing by time gives 6.25 milliamps. These examples show how current depends on both charge and time. Current is measured with an instrument called an ammeter. The ammeter must be connected in series so that the same current flows through it as through the circuit. It can measure in amperes, milliamperes, or even microamperes depending on the range. When converting, match the positive lead to the positive side of the supply and the negative to the negative side to avoid damaging the meter. To summarize, electric current is the rate of flow of charge through a conductor driven by a voltage difference. Its units is the ampere and it's measured using an ammeter connected in series. Remember the core relationship I equals Q over T, linking flow, charge, and time. Thank you for watching.